Okay, let's continue to solve equations using the quadratic formula. There's some little challenges in the next round just to be aware of. Again, the goal is to use the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our goal. All right, and when you look at these, this one it's really not in the form that we need, because to build this formula we had this, all right, that's a plus there. So we had the polynomial set equal to 0. So it's a lot like factoring. We've set things equal to 0 and we factor. Same thing with the quadratic formula. All right, so the first thing we need to do here is to subtract 13 from both sides. So that way I have it set equal to 0. And now I can accurately define who A and B and C are. So A looks like it's 1, B is 12, and C is negative 13. And so now that I know that, I can go to my formula and start plugging things in. So we get negative 12 plus or minus, that would be 12 squared, minus a 4 times an A times a C, all divided by 2 times 1. And there you have it. So we got x equals, that would be a negative 12. 12 squared is 144. And 13 times 4, let me kind of do some scratch work there. 2, 1 is 52. And we have a couple negatives, so that would be plus 52, right, all over 2. And if we continue, this is negative 12 plus or minus 144 and 52. That's 6, 9. That's 196, all right, all over 2. And then I believe this is actually 14. Let me double check that. So 4 times 4 is 16, carry the 1, and 14, yep, 196. So we get x equals negative 12 plus or minus 14 all over 2. And so there's two answers, right? There's negative 12 plus 14 over 2. That's x equals 2 over 2, which gives us x equals 1. Or we have negative 12 minus 14 over 2. That's negative 26 over 2. X is negative 13. So there's our solution. So again, the first thing we had to do was get it set equal to 0. That helped us determine our ABCs. And then we put them in the formula and we're done. Next one has the same problem. We're not set equal to 0, but it is a quadratic. So how about I move everything this way? So I'll add 3x to both sides. And I'll subtract 12 from both sides. So that'll give us x squared plus 3x minus 10 is equal to 0. Of course, I would actually factor at this point, but since we're using the quadratic formula, right, my A is 1, my B is 3, and my C is negative 10. And so plugging it into the formula, we get negative 3 plus or minus, we're going to take 3 and we're going to square it, 4 times A times C. Right, all over 2 times 1. All right, and so we're off to the races there. Let me make sure well, that's a minus 10 right there. And so we get x equals negative 3 plus or minus 3 squared is 9. 4 times 10 is 40, and we're subtracting. That'll be a negative 40. So we're going to end up with a plus all over 2. So x equals negative 3 plus or minus the square root of 49 all over 2. And so that becomes negative 3 plus 7 all over 2. And so we have one potential answer is 3 plus 7 over 2. That's 4 over 2. So x equals to 2. The other answer is negative 3 minus 7 over 2. That's negative 10 over 2, giving us negative 5. And if you factored, you guys probably could have saw that a lot earlier. But like I said, we're learning the quadratic formula, so let's use it. So again, these two had a problem that we weren't set equal to 0. Okay, so what about the next one? Well, down here, we're not set equal to 0, so that's one problem. And then over here, this isn't even multiplied out, right? So we have all kinds of issues. So kind of like we did back in the day when we were factoring, we probably need to kind of work in reverse. So let's FOIL this side out. All right, that would give us x squared minus x minus 2. And then set it equal to 0. That gives us x squared minus x minus 5 is equal to 0. So now we have the situation we need to use the quadratic formula. So in this case, A is 1. It looks like B is negative 1. And C is negative 5. So my solutions plugging it into the formula, we get that. Oops, and a is 1. Doing that. And so x equals, this would be a negative of a negative is a 1, positive 1, plus or minus, negative 1 squared is 1. 4 times 5 is 20. We're subtracting a negative, so that would be plus 20 all over 2. And so in this case, x is 1 plus or minus the square root of 21 all over 2. That's a 2, 21. And again, there's two answers there, but they're not very nice, right? The square root of 21 is not a real number, or excuse me, not a nice rational number. So it's still real, but just not nice. And again, there's two answers: the one plus the square root of 21 over 2, and the other one is 1 minus the square root of 21 over 2. So be aware of that, of our two answers. So good to go. So that started with some problems and we fixed it. The last one, again, if you're sadistic, you can leave it the way it is. A is 1/3, B is negative 1/6, and C is 1/4. And yes, you could take all those fractions and plug them into that formula and be okay. But why don't we go here, right? The idea is I need a coefficient equal to 1. That's usually very nice. And that can be accomplished, all right, by multiplying everything through by 3, but that's still not going to get rid of all my fractions. So how about we use the old idea of clearing the fractions and then using what's left. So I think the LCD in this case is 12. So I'll multiply both sides by 12 over 1, or 12. That side's still 0. 12 divided by 3 is 4. 12 divided by 6 is 2. And 12 divided by 1/4, or 4, is 3. So there might be a nice way to solve that one, which is to first get rid of the fractions. And that's kind of something we've done in the past, and we're going to see it again. So in this case, my A is 4, my B is negative 2, and my C is 3. And so we just plug everything in. So x equals negative b plus or minus my b squared minus my 4 times my a times my c. And that's all over 2 times 4. And so we get 2 plus or minus, I think we're going to get a 4 there. And then here we get 12 times 4. I believe that's 12 times 4 is 48. All over 8. And so x equals 2 plus or minus, we get a negative 44 all over 8. And so now we just have to clean this up. 44 breaks up into 4 times 11 times negative 1. So if I take the square root of all that, I get 2 plus or minus 2i square root 11 all over 8. Okay? To reduce my fraction, you can either break it up into the two fractions it is, or how about I just do this trick? Let me factor that 2 out of there. And now that 2, right, shares a common factor with that 8. So our final answer will be 1 plus or minus I square root 11 all over 4. All right, so complex roots in that case after we cleared those fractions. So there's some harder cases. Again, make sure your set equal to 0 before you put in your formula. Make sure it does fit the general form before you plug anything in your formula. And then the whole idea, if you have an equation with fractions in it, clear them, all right, by using that old trick of multiplying by the LCD, and then start plugging your coefficients into your formula. All right, so one more idea to finish, and then we're done with 11.2. See you guys in the next video.